Welcome to the Foundry by Forge College. I'm your host, and I'm absolutely thrilled to have you back for this explainer. Now, first things first, a massive congratulations on surviving our last module. You know, the one about the existential dread of adoption challenges? Yeah, let's be honest, it's a minor miracle we made it out of that one without pulling all our hair out. We spent a ton of time analyzing the friction, the pushback, and the generally messy realities of integrating new tech. But Today we shift gears. We're going to take all those scattered puzzle pieces we've been agonizing over and finally assemble them into a beautifully functioning working engine. We're talking about the complete synthesis of blockchain fundamentals.
Okay, let's dive straight into this architectural blueprint. We've got a great agenda today that'll take us from a chaotic pile of parts to a fully synthesized engine for your capstone. We'll kick things off with from pieces to whole, then explore the replicated transaction engine. After that, we'll be tracing a supply chain, setting up a resilient design workflow, and finally, finalizing your capstone. Let's get into it. Section 1. From pieces to whole, connecting the dots. We are officially done with the problem-focused analysis, so no more stressing over what goes wrong or worrying about organizational resistance. We're moving directly into synthesis. This is where the theory you've learned becomes actual practice, and those isolated concepts finally start talking to each other. To pull this off, we've got to start by tackling a pretty massive, slightly intimidating question. How exactly do we connect existing enterprise databases to new ledger-based systems without the whole thing turning into a chaotic mess? If you recall from our last lesson on adoption constraints, the friction of connecting legacy systems to new ledgers usually creates a massive headache for developers. Honestly, it's kind of like trying to plug a brand new, lightning-fast smartphone into a rotary dial wall outlet from the 1970s. The protocols just don't naturally speak the same language.
And here's the harsh reality of enterprise engineering. It's almost never the fancy cryptography that fails. Instead, integration points, things like your APIs, data mappings, and governance policies, almost always become the single largest source of project risk. It's the glue holding the old and new systems together that gets messy. These integration points massively increase your coordination costs, and they practically limit your technical choices, like your consensus tempo and permissioning structures. Think about it. If your API gateway is a sluggish bottleneck, it literally doesn't matter if your underlying blockchain can process thousands of transactions a second. Your entire system? Yeah, it's only as fast as its slowest integration point.
Section 2. Replicated Transaction Engine, the Architect's Blueprint. So, to reduce this cognitive overload and bring some absolute order to the chaos of integration, we need a single, portable mental model to guide our designs.
So, what exactly is our core blueprint? Well, it's a replicated transaction engine. That's a distributed state machine that applies ordered transactions to reach a shared state. Now, I want you to completely stop thinking of the blockchain as some kind of arcane, impenetrable internet magic. Instead, visualize it as a factory assembly line. Raw materials go in at one end, they get sorted, stamped, verified, and then a finished, perfectly identical product comes out the other end for absolutely everyone to see. It is, quite literally, a replicated engine for processing transactions.
Now, this engine neatly divides into three beautifully clean, interacting planes that separate your architectural concerns. First up, we have the transaction plane. Think of this as the intake valve where creation and preliminary validation happen. Second is the ordering plane. This is the conveyor belt where nodes actually agree on the exact sequence of events so nothing collides. And third is the state plane, the final ledger where those agreed upon updates are permanently applied and propagated out to the network. By forcing your mind to split the system across these three distinct planes, you isolate the moving parts. If something breaks, you know exactly which department of the factory to investigate. And this perfectly illustrates how the components you've been sketching out map directly into our engine's blueprint. Notice how clients and gateways sit right there in the transaction plane, constantly forming and signing new requests. Meanwhile, the consensus layer lives entirely in the ordering plane, establishing that absolutely crucial single sequence of truth. And down below, your state engine and replication nodes live in the state plane, doing the heavy lifting of applying those transactions to the historical record. Having this exact mapping in your head shows you precisely where to insert instrumentation or where to deliberately throttle the load when the network gets dangerously heavy.
The real magic here is that abstract trade-offs suddenly become incredibly actionable engineering tasks. By strictly isolating these planes, you can answer complex architectural questions with pinpoint accuracy. For example, imagine your boss suddenly asks, "Hey, if we need sub-second finality for a new high-speed financial app, which specific part of the system do we need to optimize?" Instead of guessing, you'd look right at the ordering plane. Or, if the compliance team suddenly demands deeper regulatory auditability, you don't go and rewrite the whole app. You look directly at the replication components in the state plane. It gives you a scalpel instead of a sledgehammer.
Section 3. Tracing a supply chain, taking the engine for a test drive. Abstract models are fantastic for passing exams, for sure, but let's take this out of the classroom and actually test drive this engine by tracing a real-world scenario. Let's look at a supplier submitting a simple goods received transaction right on a loading dock. Watch the assembly line in motion across these 6 distinct steps. Step 1. The gateway translates a messy, legacy ERP payload into a clean blockchain transaction. Step 2. It securely queues up in the mempool, just waiting its turn. Step 3. The network actively gossips the data across nodes. Step 4. The validators step in to order it and officially include it in a block. Step 5. The state engine executes the logic and updates deterministically. And finally, Step 6. The brand new final state is fully replicated and confirmed across the globe. You are literally tracing the exact flow from a chaotic, physical event on a loading dock all the way to deterministically updating an immutable ledger. How cool is that?
Now, notice how your finality model at the end of this line entirely dictates how long a client actually has to wait to trust the result. This isn't just theory, folks. It's pure user experience. If you architect for deterministic finality, you get immediate confirmation right upon execution. The supplier knows the goods are logged the exact second the block hits. But if you design for probabilistic finality, your clients and your suppliers have to wait for several additional blocks just to be mathematically sure the transaction won't be reversed. It makes a massive difference in how snappy and responsive your entire system feels to the end user.
Section 4, Resilient Design Workflow, your instruction manual. With the engine running smoothly in our minds, I want to hand you a repeatable, step-by-step workflow for designing resilient ledger solutions from scratch.
This sequential checklist is your ultimate guide for drafting your capstone. When you're building enterprise architecture, you don't just wing it, right? You follow the steps, much like an airline pilot running through pre-flight checks. You strictly define your success criteria first. You neutrally choose your consensus pattern based on pure logic, not just picking your favorite trendy vendor. You meticulously design your replication, and you deliberately test your failure modes because, let's face it, things will fail. This checklist ensures you don't panic and miss critical elements like upgrade paths or governance rules when the deadline pressure is breathing down your neck.
And here's an absolutely crucial target to keep in mind while running through that checklist. 30. As in, a 30-minute recovery time objective. Because remember, properties like a strict 30-minute RTO aren't just rhetorical ideas tossed around in pitch meetings, and they certainly aren't marketing fluff. They are hard, testable, measurable engineering targets. You absolutely must design your replication and state management planes with enough redundancy and speed to ensure that if a server farm literally goes up in flames, you can hit that recovery target flawlessly. Let's look a bit closer at one of those specific checklist items, planning integration boundaries. By making these boundaries explicitly clear, I'm talking about mapping out exactly where your gateways, your APIs, your adapter layers, and your translation rules sit. You directly mitigate those massive project risks we identified earlier in the course. If you know down to the exact byte how the rusty old legacy ERP system talks to the shiny new blockchain ledger, you strip away the chaos. You contain the mess to specific adapter layers, keeping your core engine completely pristine.
Section 5. Finalizing your capstone, from theory to masterwork. As we prepare to shift into our next phase, which is applying concepts to industry challenges, it's time to formally frame your capstone project using all of these newly synthesized tools. The absolute golden rule for your capstone project is this: document your technical trade-offs against adoption realities with complete transparency. In your proposal, use a short, clear table to outline your design decisions and the alternatives you considered but ultimately rejected, and explain why you chose them. This is what proves to industry reviewers that you've truly absorbed the concepts from your Forge College courses. It shows you aren't just an idealist. It proves you can perfectly balance elegant, beautiful code with the messy, complicated, and often frustrating constraints of the real business world.
Which brings us to the final challenge I have for you today. Take a moment to really think about this. How will you map your specific industry use case onto these 3 interacting planes to build a truly unstoppable engine? I'm going to leave you with that provocative thought to ponder as you start sketching out your masterwork. To dive deeper into this framework and explore a wealth of other amazing Web3 topics, be sure to visit forge.college. It has been an absolute pleasure guiding you through this material, and I'll see you in the next Explainer.